We have Logan, who is an application security engineer at OverDrive. He was a developer for a number of years, moved over to application security, and we're going to actually start off by asking a little bit about his journey from development into security, what made him go for development in the first place, and what made him move to security as a field. Because, like when we spoke with Corey, the path is one that, at least to me, is incredibly logical. I look at it and I say, well, of course, going from this field into that field, that makes complete sense, and it gives you greater capabilities maybe than the more standard, more common pathways. So I guess if you can start off with what what is your educational background, and why did you move into development, actually?
Yeah. So, in a lot of ways, I started in development as a pretty young child. My dad was really one of the first major wave of university taught computer science people, when it first really started taking off.
That's awesome.
He actually has stories about how his teachers would tell him that computer science was a waste of time. It was just going to die out like a fad.
Huh. What
It,
around what time was this? I just for
in
everyone's.
the 70s and 80s,
Yeah, yeah, that's
more or
that's what
less.
I figured.
Yep.
Yeah.
Yep.
Hey, you're
So,
lucky. That's awesome. I never had access to that. That is so. God,
yep.
man.
Yeah, from his stories, it was a very different time. And well, his background did involve some computer security, but I'm afraid that was more. He he had his father was relatively wealthy and was able to get, I think it was a Apple, one of the very early Apple computers early on, and he was willing to let my dad play with it. So long as, my dad didn't break it or anything along those lines, because it was not a cheap device then.
Right.
But my dad quickly found that it was more fun to reverse engineer and play with the programs than it was to play the games that was on the device. So that's what he did. And, he was pretty good at it and, went through school, all that sort of stuff. And then, I eventually came along. So one of my first memories is an Amiga. Playing games on that and fiddling with things a bit there. And, like throughout my childhood, my dad would be programming in the background and, I'd come over, take a look, do some listening, act as that rubber duck that the developers so often refer to. Yes, it works for children too, and they can even learn things sometimes.
Actually, I like that because number one, the I think one of the most important things as a parent that I can do for my children, obviously, is expose them to different things, which is what that does. And number two, I can, if you treat them like an adult and talk to them like an adult, they will act like an adult. They will think like an adult. And you'll get people who, I mean, everyone does their best, and no one here is perfect. But you'll get people who baby talk with their kids well past the age where that's typically acceptable, or they'll hold their kids back. I don't want to I don't want to use this term because I think it's a little overused, but I will say helicopter parenting. Again, I think that's overused. Just where they coddle the child, where that the individual isn't given the chance to grow, but by exposing you to it early, exposing you to, I'm going to say adult conversations, but not in the way people think of it. An actual adult conversation, not one on adult topics, if you know what I mean. I think that helps to create more emotionally savvy and logical thinkers, but it also let not to steal from you, but it also let you experience a world that you would not have had access to if you weren't given the opportunity to be involved in your dad's work in some way, shape, or form. I know in my case, I had a similar experience with my parents where we would go to their workplace. It's a very different workplace, but we would go to their workplace. And growing up, at least for me, I thought that was very helpful, especially because you're now around other adults and in appropriate but different situations than many of your peers. It helps you really grow up, I guess, and just have more experiences than you would otherwise. I'm sorry,
Yeah.
please continue.
Yeah, no, yeah, like, and it really was an excellent learning opportunity. And yeah, as I got older, got an IDE, I'd write some simple programs to do various things, solve various challenges. I did a bit of work helping my dad on his software, which incidentally, this may or may not be important later, but one of the things his software does better than the competition in a lot of ways is be a lot more efficient.
Mhm.
So one of the big complaints with modern software is it's a lot slower,
Yeah.
right? I mean, it does much of the same things that software from like say the 2000s did,
Hmm.
but it's still just as fast because despite the way the power of the hardware has increased, the power of the developers have decreased.
Yes, that's very true. That's incredibly true. And I don't know about you, but I know there are two components to it. One of which is a little, I guess, politically sensitive, so I'll steer away from. But the other is the agile mentality of the fail fast, fail often, which, and then they've pushed as a result the debugging and everything else further and further onto you, the user. Yeah, the optimism. You're exactly right. In today's day and age, the code is nowhere near as efficient as it could and should be for general software.
Yeah, and like I think I don't entirely agree with what you said there.
Okay.
And I think part of the problem is the developers, but and it is certainly agile because again, if you want to write efficient code, you need to plan for it.
Mm-hmm. That's true.
But I also think part of the problem is the sheer number of libraries that developers are using. And it's often the case of you're not writing the whole thing from scratch anymore. You are using libraries or third-party code, you're integrating it and using it. That's how you do development work. The
Right.
problem is those individual components you're using frequently do a whole lot of other things that
Right.
your actual software doesn't necessarily need.
Yes.
So rather than doing your relatively simple operation, at least that's what you want, it's very quick and easy to write, but if you actually look at the back end, you end up spending a lot of time preparing for things and doing other operations that don't actually make sense for you to be doing in your situation.
Yeah, actually, that's really true. You're exactly right. We at least to I think a fair degree over rely on other people's libraries and other people's just third party software in general, and we will. Oh, well, I want to do image rendering. Okay, well, what do you need to do with this image rendering? I just need to make a thumbnail. Then why are we importing the entire image.io library? How much are you going to
Yep.
use? And is that really the right library? In fact, do you need a library if all you're doing is taking a JPEG, an existing JPEG, and shrinking it? And the answer is no, not really, not
Yep.
usually.
Yep. Exactly. And it's that sort of thing is often invisible to the developer
Mhm.
because they have the library and they just use it, right? But yeah, so in a lot of ways, that's how I spent my childhood. More or less skipping over the various school years up until university. I was in a relatively poor area. Computers were not available in school, so that didn't really have much impact. But again, plenty of computers at home. Every time my dad would get a new computer for whatever reason, uh, his old computer would become my computer, and my old computer would become my sister's old computer, and my sister's old computer becomes my mom's computer, and so on down the line.
We have a similar line here.
Yep, I I anticipate that being pretty common because yeah, that makes sense. But yeah, eventually, so yeah, complete high school, go to university at OSU for computer science. I learn a bit. Again, I wasn't overly impressed by the quality of the computer science taught at Ohio State. Now, part of that could well be because a lot of it, they made the fundamental assumption that you had never programmed before in your life,
Mm.
and which meant that a lot of the classes that we were required to take to get the degree were, I always felt of them as a waste of time
Yeah.
because they taught concepts, procedures, processes, things that I already knew. Uh, on the other hand, there were others where I did learn a great deal.
Actually, can we take a minute? I do want to delve into that, and I want to delve into that for a few different reasons. First and foremost, I mean, I have a computer science degree. Roniel has a computer science degree. We've talked about degrees before. I do not like cybersecurity degrees, and that's not really what we're talking about here. But I don't like them because they're too broad. They're non-standard. That program is non-standard, and you don't learn key things that you need to learn in order to be, I would say, a technical and successful cybersecurity professional. By and large, what you learn is enough to do very high level, almost more program management stuff. But I do have an emphasis on computer science, but I also know, having hired a lot of people and having done a lot of interviews, I have my own opinions on certain colleges, and they echo what you're describing with regard to a certain school in particular. But do you so let me compare and contrast our experiences really quickly, because I'm hearing more and more actually what you're talking about from other people who are telling me about their experiences currently in college. And I know I went through and was going for a master's, and I was not challenged, and literally I had two classes left, and I said, you know, i'm I'm doing this just for me and just for the knowledge. I'm going to wait and go somewhere else, because this university, the one I was going to, it's not teaching me anything new. And since it was a master's, it didn't matter. A bachelor's is a different story. But so for my bachelor's program, at the very first class I had to take was a programming class where they went through methods, variables, classes, inheritance, polymorphism, all of that stuff. I mean, and it was a big deep dive, and they were using Java actually for that. And that class, I think, is what I would say was very much oriented toward people who had never programmed before, and who weren't familiar with a lot of the C and C++ concepts, because this was a long time ago. Java was actually very new at this point. And anyway, but the other classes, all of the other classes, like you and I have had discussions where I've talked about, okay, well, mine, they after that class, none of them were like that. So we had a C and C++ class, but it wasn't geared toward people who had never programmed before, because they'd already dealt with that in the very first class. It was, I think, CS 153 or 150, or I don't even remember what it was. So all the others were very hardcore, but they also went deep into the theory behind it. And we had to do a lot of reading from Dijkstra. We had to do a lot of reading from Lamport. We had to read and hear about Therac 25. We had to do just massive amounts of reading of all these case studies. And in the parallel programming class, for example, you're talking about the Byzantine general problem. You're talking heavily about race conditions, starvation, live lock. You're talking about network jitter and all of this stuff. But it was in class, it was very theoretical, very high level. And then you would have to take all of that, and we would have to write software that demonstrated this thing, whatever it is, so race conditions or what have you, and it very specific guidelines. And then we'd have to create a version where that was fixed. Is that Does that jive with what you were getting in
Yeah.
general or not?
So to an extent, certainly your initial experiences to show the introduction to basically explain how to do basic programming. Absolutely. They also had a variety of essentially 1 credit hour courses. So that's 1 hour a week of, hey, go ahead and learn this language or that language or what have you. I ended up taking a couple of them because I needed the hours to qualify the degree. And hey, I hadn't worked in those languages, so why not? Um, Again, they weren't really a deep dive. They were very much so more of a hey, so implement a program that does this in this language.
Hmm.
And there wasn't really any teaching or anything involved.
Oh, it's kind of
So,
depressing.
yep. Equally so, there wasn't any analysis of history.
Mm,
So there's no referencing to Dijkstra, to your Byzantine generals problem, none of that stuff. What we had instead were, I would say, a lot more aimed at product and project management
mm,
type of stuff. So you're like how to actually do the waterfall method from the top down. That was a fairly large class. We had some computer science theory pieces. I always liked the class that covered finite machine automata or
yes.
finite. I can never remember that,
Right,
but
right. Yeah, yeah,
effectively
yeah.
it was very much so based in the rather than doing the code, a lot of the theories behind what you're doing, how to manage states, some touching on efficiency, things of that nature, which I thought was pretty interesting. We had a class on computer graphics, which I think would have been a lot more interesting if the instructor hadn't simplified things as much as he had. He Rather than teaching how to do computer graphics, he created a tool set that essentially just let people say, "Hey, in these coordinates in your plane, just put a polyhedron of this shape." So because of that, you sort of lost a lot of the "this is how it actually works" in the back
Right,
end
right.
piece. Did, however, make it a lot easier for him to get the class to produce things that were a lot more impressively visual.
That's interesting. See, mine. I guess it sounds like we had. They were not. I want to be clear. They weren't diametrically opposite, but they were very different. I'll put it that way. They were
It,
very different experiences. Like, so I had, of course, an operating systems class. I had a data structures class. We had
I had an operating systems class. It
okay,
was
what did you have
on,
to do in that?
so it was based on the RISC architecture. We had to essentially write some limited assembly to accomplish various tasks. Uh,
Hmm,
Again, like it was interesting. We learned a lot about the different operators, how the registers work, things of that nature.
right?
We had to do some diagramming of how to basically connect all the pieces together.
Hmm.
But it was frankly a long time ago, and I've never used it since. At least not beyond that high level understanding of how to do it. Like, if you sat down and asked, "Hey, can you write a program to do that to do this relatively simple thing in assembly?" My answer would be, "Give me a couple of days and access to Google."
Oh, but
But
that's, can we be honest? That is, I've mentioned before, at least to me, a real computer scientist can take, I know, no true Scotsman fallacy, but a real computer scientist to me can go through and take a set of requirements, be told, well, take a set of requirements, figure out the proper language to do this in, and then it can be a language they don't know, but they can just look at the API for said language, figure out, look at the grammar for said language, and then write the code, and it doesn't take them that long. Whereas other people who maybe aren't as experienced or as, I'm going to say, traditionally educated in the computer sciences will take longer, struggle more, and the code usually won't be as tight. Obviously, everyone is different, but I think it's, to what you're saying, it's that ability to pull up documentation, read it, and say, okay, well, based on this documentation, here's how I need to lay this application out, and they'll be able to do
Yep.
it without going to tutorials all over the place and Stack Overflow all over the
Yep.
place and all that kind of stuff.
Yeah. No, like if you're using like you, yeah, you have to. I mean, like effectively, your design phase here is you design your program, you identify what it needs to do. Next step, at least for me, is usually any language you're going to have ifs, loops, things of that nature, right? So I just start writing the program, figure out how to get those to work in whatever language I'm writing for, and then more or less write pseudocode out, right? Just identify, hey, this is what I'm looping over, this is what it needs to accomplish, things like that. And then it's like, okay, how do I actually do this? And
Right.
that's when I start doing the research. I don't necessarily go directly to the API documentation in full. It tends to be more, how do I accomplish this relatively simple
Right.
thing? And I usually find that like after 2 or 3 searches, you've got enough to write a pretty simple program in that
Right.
will do what you want. It's not necessarily going to be the most efficient. It's not going to be the most pretty, but it'll get the job done.
Okay, right. I do agree. Now, for my operating system class, we had well, we actually had to write our own operating system. And again, so the classroom in the classroom, we're again looking at theory, we're looking at case studies, we're looking at history, we're analyzing the Unix and Linux and Windows kernels. Uh, we are discussing how they operate and all of that kind of stuff. And then we had to go home and we'd have an assignment. You will now write the scheduler. And there we are creating the scheduler. And at the end of it, you've written an entire operating system from scratch, from start to finish. And then, but, and there was hardware. Hardware was there. We of course discussed hardware because there's no way you can discuss schedulers and all of this other stuff if you don't. But we had a hardware class specifically, which is where we went hardcore into this. It was a processors class actually, but that processors class did the whole EE thing where you're going through all your gates and all your transistors and all of that stuff, and we had to put together transistors. And from there, the goal was to create an actual processor, but you also had to create the corresponding language and build it all out so that you had a working CPU kind of deal. And we did risks for that one, not CISCs, because of course in class we discussed both and we're going through both. So we were in class. Okay, well here's MIPS and here's the MIPS language. Here's Intel. Here's the different Intel architectures. At the time, I don't think 64 was out. I think it was still 32 and 16-bit processors, but it may have been 8 as well. Anyway, the point being, we focused on that in class, and then at home we had to go through and create all of this. So mine was very much that here's the theory, and then you implement it. It's up to you to implement it, kind of deal. But we broke out a lot of the stuff. We had a networking class, which I mean everybody does, right?
Yep, we did as well. We had a networking security class as well that I'll be honest, I learned a hell of a lot more in that one than I did in the networking class.
We didn't. So security wasn't actually. It was new at that time as a course of sorts, and where I was, it was a graduate level class, and I actually took it in. I think it was like my freshman year, which caused an uproar when the professor realized I was a freshman. Was not happy. It's like, well, I've been doing this for a while at this point, and it was very theoretical. Again, I mean, the class it followed the same format. The class, the lectures, very high level, very theoretical. You're talking Bell Lapodula. You're talking, write up, write down, all of this other stuff, and then you go home and you have to create software based on what the lectures were just actually applying that high level theory. but we didn't have security back then. It was not an undergraduate class, and I know that's something. So Roniel went to computer science after I did, and I believe your program was after his. Maybe I don't know the chronology of all of this stuff, but I would love to see a mapping out of these how things have changed over time. I know we went to 3 different universities, but I think that might be, at least for me anyway, that would be interesting, and it would be really neat if we could get a mapping that ties it way back to people like your father who just that was a different time. And having spent my entire college years reading from touring and so on and so forth. So you're talking about reading papers from the 30s, 40s, 50s, 60s, 70s, 80s even. I really do think that's so neat. That's cool. It's like with martial arts when you find someone who actually trained with someone from way back when, and you're like, oh god, I need to steal as much data from your brain as I can. I can learn it by
Yep.
proxy.
Yep.
So
Yeah. Okay, like honestly, from what you've said here and comparing it to what I remember from my university, I'd say the biggest difference is it sounds like you actually had more or less a degree. Like it was cohesively planned, it was all integrated, it came together, it taught
yes.
you that broad base and did everything.
Hmm.
So OSU, I think the only actually required class was that basic programming class.
Oh,
Past that, you had to meet X number of credit hours in a variety of different fields. So you needed to have your I think it was like 30 or 40 in mathematics, 30 or 40 in computer science classes. I think it was 20 or so in electronic engineering, like 5 in physics, chemistry, history, English, things of that nature.
right, right, right.
But there often wasn't a whole lot of planning around things, if that makes sense.
Ah,
So it was
yeah.
very much so a case of you cherry pick the classes that you thought were interesting, that looked, like they would teach you what you wanted to know.
Oh, that's different.
But yeah, but what's it very much so sounds like was missing was sort of that history of computing
Hmm.
to essentially tie it all together. So, like, say, as you described in your processing class, mine we worked with a specific processor. I want to say it was Spark was essentially the name of it.
Really?
Spark 5 or Spark V. I think it was just SP. I
Right.
don't
Yeah.
remember how
Yeah.
it was
Yeah.
spelled, but yeah, it was a specific model. And that's what we'd effectively work with. We'd analyze it, talk about the differences between it, between RISC, between CISC. It was a RISC processor. Um, we'd write some relatively simple programs for it, things of that nature. But we certainly didn't say, as you did, write all the components of a actual operating system throughout the course history.
Oh, that's
Um,
that's interesting.
yeah, so
That's
yeah, we
interesting.
had yeah. So it's sort of like like there were certainly the various pieces there, uh, but it didn't feel like it was very tied together.
Yeah. Yeah. That's unfortunate. And I will say so. My youngest son actually has begun taking computer science classes in college in an Ohio university, and I actually was very disappointed, and he was disappointed. And this is going to be very different than what you described. So he took a class, and his first class was on C sharp, and they got as far as variables and methods. And variables, we're talking, of course, instance variables, class variables, method variables, statics, static variables, all that good stuff. They did, of course, go into scoping and visibility a little bit, but they didn't get into classes, for example. And the only reason, see, but he'd already, I mean, he'd been programming for a long time. It was something he liked to do, and it was something that he's been doing since he was young. And he was disappointed. He was disappointed, and I was disappointed hearing, because how can you take a computer science class And granted, it was the introduction to programming and it was for C sharp, but how do you not discuss classes?
Yeah, I don't know. I mean, like even the ones I did, we did discuss. We discussed it all. Like, essentially all the different components, how to make it work together. We'd write programs that utilize them. Now that said, rather than being a 1 quarter or 1 semester or 1 trimester, or however much they worked it out, it was a full year-round course, at least
Oh,
initially, to cover it all.
really?
So yeah, so I
Oh,
think
well, that's
at the
different.
time they divided into trimesters, so it was essentially a full series of courses.
Huh.
Um, so that may well be the difference there. Um,
See,
but
mine was 1 semester for
yeah,
that part. I mean, every class was 1 semester, but they moved us along, and really, it wasn't until you got to the 400 level that you had any choice. Everyone had to do operating systems. Everyone had to do data structures and introduction to programming, and I don't remember the names of all of them, but the C++ class, which wasn't, they used C and C++, but it wasn't a C and C++ class. I don't. I, that's interesting, and really, like my choices in the 400s, I did artificial intelligence and I did algorithms for my 400, and those were the only two electives I had because, of course, you had to take two classes that were electives within computer science, but the rest were all mandated. Everyone will take these classes, and it will be in this order because it told that coherent story throughout the whole thing, where you're working with the hardware, you're working with the operating system. Because how can you do the operating system if you don't understand the hardware? That's something else I haven't understood is the computer science programs where they don't do the EE side. And ours, you could get an EE, you could actually triple major. You just had to pay $20. Math, electrical engineering, and computer science. And then a lot of people picked up physics because we had to take a lot of physics too. So they'd just pick up physics anyway because, I think it was just one extra class you would have to take. I wasn't going to pay extra money. I would not advise people do double and triple majors, but that's a different matter.
yeah, yeah, and so the single biggest mistake I made with Ohio State was I signed up for honors engineering.
Hmm.
Now, that sounds like a good thing, right? I mean,
Right.
you get access to the more challenging classes, things of that nature. Well, as it turned out, what honors engineering meant was that you had very little flexibility as to what classes you took in your first year.
Ah.
So it was very much so less of a university and more of a hey, here's a fifth year of high school.
Ah.
Now, I would have been less upset with that, except that I had gone through the International Baccalaureate program.
Right, right, right.
So I came into college with a bunch of college credits for all of these classes. And then OSU said, yeah, well, yes, you have credit for them. You have to take them again because you signed up for honors in engineering. And oh, by the way, because I was an idiot and this was very much so my fault, I did not look and read through what it entailed initially. I was just, coming from the Australian background, going for honors is usually you get more challenging classes, more interesting, you learn faster, and that lets you in turn graduate faster, which, saves you a whole bunch of money.
That's the point.
Well, OSU's was not like that at all.
That,
So
yeah, that doesn't
that
shock me.
yeah. Yeah. So that let's just say I was not very happy when I figured that out, especially since it basically just obviated. Yeah, I'm not going to get into that. Let's just say that was not a fun discovery.
That makes a lot of sense to me. That makes a lot of sense to me. I know I know. See, I think I don't want to get a lot of hate, but I'm going to go through and say it. So one of my biggest issues with Ohio State is they seem to think that they are better than they are. What you're describing is the kind of thing I hear from Harvard. And it makes sense, or MIT, and it makes sense for Harvard and MIT. They'll accept your AP and international baccalaureate credits, but they don't accept the classes, if you know what I mean. You still have to take the
Yep.
classes, and their stance is, well, ours is just at a higher level. But
They're
Ohio
not.
State isn't there. Yeah, right.
No.
They never are. Honestly, they never are.
Yep.
Ohio State isn't there, and the university comes off as a little arrogant to me, like how they demand people say, I've had people, and you say, oh well, Ohio State, and they go, it's not Ohio State, it's the Ohio State, and I'm like, okay, well then it's not Colorado State, it's the oh wait, no, there's only one of each. You know?
Yep. Yeah, and yeah. Well, either way, yeah. I think if I could do it over again, I would probably pick a different university. On the other hand, I would like to think that anybody given that chance would probably pick a different university because they've already done that one.
That's true.
What are they really going to learn it again?
No, that's actually a really good point. Look, you already got what you were going to get from that university. And like we've discussed before, look, I can take a phenomenal student and put them in a bad school, and they will do significantly worse than they would have otherwise. Will they still learn stuff? Yeah. Similarly, I could take a really bad student, put them in a phenomenal school. Will they do better than they would have otherwise? Maybe, maybe not. But I think it's important to recognize that there's a type of learning for each individual. And if you go to a different university, this is actually why they generally recommend you not get a master's from the same place you got your bachelor's from, because they're going to have a different philosophy, they'll have a different learning style, they'll have a different emphasis, and exactly to your point, you will be exposed to something completely different. So I completely agree. I think regardless of, well, Ohio State may be a fantastic university, or maybe a bad university. That doesn't matter in the end, because if you go to another university, it could just be Ohio State was the wrong university for you, right? It could
Yep.
be that this other university is the one, and suddenly everything clicks, and you're going, oh. And so Ohio State may have been a good university for you, and some other one may be a bad university, vice versa. But that's where that exposure comes in. I enjoyed where I went to school. I do not like how it is today. I think their quality of education has dropped. And I mean, like I said, I mean, I stopped a master's program over it. And, you know, to exactly your point, I can't see myself going back there for a master's, because it's like, no, I've already done that. I'm done. I can't see myself going there for a bachelor's. Done that. I don't want to do that again.
Yeah, and we were now. Don't get me wrong. Like there were certainly classes that were great fun. I
Mhm.
learned a lot. But there were also a lot of classes that I didn't really learn a lot.
Yeah.
So it was a bit of both. Yeah, and I
Yeah.
have some interesting memories. We had to take a history course. So, I figured, well, okay, I'll just take art history. How hard can it be? That is a lot of memorization.
Yeah, I liked art. I could never do art history.
Yeah. But look, yeah, it was a valuable lesson. Yeah, I learned a lot that, I don't like memorizing large lists of names of paintings, authors, and years.
Hmm.
Not a great experience.
Yep.
Um, Another more fun class was material science. That was actually pretty interesting. And
Yes.
again, it's not something that I really use in my day to day. At the same time, it's one of those things that, actually thinking about it, like it does help. Sort of, that express that, hey, pick the right materials for the job and know what the difference between them are and actually understand things to a level. Like it's not
Right.
so much what's actually taught in the class, it's the lessons that go with it.
Yeah. I agree.
Not sure if I explained that well, but
No, 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 no.
it's
That
almost like the philosophy behind it, right?
right. That's exactly right. And I think that's so something I tell people all the time, at least from my experience and from, so there actually two different major schools. You have the Prussian model, and then you have what's called the classical or English model. I won't bore everyone by getting into this in this particular episode, but someday maybe I'll get into it. With the English model, the big emphasis is on teaching you how to learn, teaching you how to teach yourself, which is really what I think you're hinting at and talking about. The Prussian model is different. The Prussian model is, those are your technical schools. They don't actually teach you how to learn. They teach you a very specific technical skill working with a very specific set of tools. That's the actual distinction between the two. But yeah, for me anyway, I think the classical model is the better one. But
Yeah, yeah. Certainly for computer science, like again, I think technical schools may work better for, say, plumbing or electricians,
right,
or to an extent, because again, a lot of it you're a lot more likely to hurt yourself if you don't know how to use the tools appropriately.
that's true.
Whereas a lot of computer science is really more about, hey, how do you go about solving the problem?
Right.
But there's less focus on what tools to use.
That's right. How do we break this down? How do we deal with it? How do we, often? I mean, I think the majority of engineering and computer science winds up aligning the exact same in that at the end of the day, you're learning how to decompose problems, and
Yep,
then you can
fundamentally.
tackle them.
Yep,
Yes.
exactly. Yeah, like you have this, giant program. Like, let's say you wanted to write a video recording software, right?
Mhm.
You look at that and it's like that. That's a lot of work. I mean, how do we do that? And then you break it out. Okay, well, we need to record video, so let's add in some stream handling. We also need to be able to record audio, so let's add in some software for that. Users are probably going to want to be able to combine them, maybe apply some special sound effects, things of that nature. All right, they're probably going to want a UI, so you just sort of keep on breaking it down until you have actual implementable pieces,
Right.
and then you break those down further and create workable designs and actually write the software for it. And if you did your design well, you put it together and it all works. In the real world, you have to do quite a lot of debugging to get there first. But that's that.
Well, that there's a reason why your software architects or software designers, depending on your organization, are considered very senior level developers. They have to have been developing for a long time and they get paid good money.
Yep.
Screw up there,
Uh,
and
it-
it's difficult. It's hard. And it's even more debugging, and that's hard debugging because it's now interrelationships and
it- Yeah, especially since if you're dealing with any sort of large complex project, you're splitting it out. Well, you're splitting it out because you're going to be assigning these tasks to different groups.
yeah,
So if your design specs aren't done properly to begin with, you're going to have these groups producing modules that can't interact with each other.
right,
And that is going to be almost impossible to fix effectively.
right.
Like, same thing, as I'm pretty sure you said previously. The earlier you get in and solve these problems, whether they are security related, technical related, or
Right.
whatever, the cheaper and easier they are to fix, and the
Yes.
less time is wasted.
Yes, that is exactly right. And that's one of the reasons why, at least in my opinion, security and selling, everyone talks about the shift left. I really hate that because it's nothing more than marketing gobbledygook. Every developer knows the sooner we get ahead, the sooner we as a team are involved, no matter which team we're talking about. It can be QA, it can be the developers, it can be the designers and architects, it could be PMs. The earlier we get involved, the better the end product, the cheaper it will be because you won't be spinning your wheels, the more on schedule you will be. It's an easy sell and developers understand it. The problem tends to be security folks don't understand how they integrate into it, which I'm going to use as a catalyst for, but I'll hold off on that, but for jumping into how you move from development into security. Before we get there, number one, do you think college was worth it? Would you do it again?
Yeah,
And then the second one
absolutely.
is just how did you move from, what did you do after college? Which,
Yep. So yeah, as I said, college was absolutely worth it. And it's not necessarily the specific information learned in the specific classes.
mm,
It's a lot more about how and why to use that information
right.
and how to keep things organized, how to do the planning, all of that stuff that you as an individual don't really need to do. Like
Yeah.
yeah, it's been very helpful.
Anyway, this has been great. I'd love to have you on again in the future. I'd love to see if we can't talk about some more of this stuff in the future. Actually, one thing I'd really like to do with you in the future is walk through some code and we can walk together through just a code scan and see what we see similar to some of the stuff that you and I have done in the past. And I think it would be interesting to have another perspective as we do this, and uh, someone who can offer just that different viewpoint, and maybe hopefully ask questions that I'm simply not answering because I don't
Yep,
think
and
about it
you
or what have
already
you.
know it
Yeah.
because, like, well, I'm not that familiar with this particular style of code scanning, at least not and having it be useful, which means that hopefully the questions I ask will be useful to other people who
Yes.
don't really know.
Yes. Yes. That would be great. That'd be absolutely phenomenal. Well, thank you so very much. I hope to see you again. Please,
Yep.
if you
So,
like this, make sure you like, comment, subscribe, and we hope to see you next time. Have fun.